Hello, this is Mr. Huber. In this lesson, we're going to continue looking at solving radical equations. This time, we're going to see where checking solutions is particularly important. Talked about that previously. It's always good to go back, put your answers into the original equation, make sure they work. It's especially important when we're squaring both sides of an equation. And we'll see where some instances come up where we may have answers that look like they work, but they don't. So we see this first example here. Don't worry that it says number 5. It's our first one of this lesson. X plus 1 equals the square root of 7x plus 15. So we know to get rid of that radical on the right side, we're going to square both sides of the equation. We want to make sure we square that whole x plus 1. You're going to FOIL that. It is not x squared plus 1. Right? We have x plus 1 squared. That's x plus 1 times itself. Okay, that's going to give us x squared plus 2x plus 1. If you need practice with foiling, make sure you're asking for any help you need. We're going to use that. You'll see quite a bit here when we're squaring things. So x squared plus 2x plus 1 equals 7x plus 15. Now we want to get this set equal to 0. When we have a quadratic equation with an x squared, we're going to get it set equal to 0 so we can use factoring. So in order to do this, we're going to subtract the 7x and the 15 on both sides. Okay. And that's going to give us x squared minus 5x minus 14 equals 0. Now this is where we need to come up with numbers that multiply to give us negative 14, add up to negative 5. To use our factoring, we're going to have x minus 7 and x plus 2 equals 0. Negative 7 times 2 is negative 14. Negative 7 plus 2 is negative 5. Remember how we can check with swings? Okay. Minus 7x plus 2x. If I multiply the negative 7 and x, I get negative 7x. If I multiply the x and 2, the swings, right? Looks like a swing. I'm going to get plus 2x. That didn't exactly write very neatly there. And when I add those, I get negative 5x. That's my correct middle term right here. So that shows me that those numbers, negative 7 and 2, worked for giving me not only the negative 14, but also the negative 5. And now how do I use that? Well, I'm going to set each of these equal to 0. So I have x minus 7 equals 0, x plus 2 equals 0, which means I get x equals 7, x equals negative 2. Those would be my two solutions based off factoring that quadratic equation. Now I need to check your answer. Check your solution. Don't forget to check your solution. Check it. So let's do that. If I check the 7, I'm going to have 7 plus 1 equals the square root of 7 times 7 plus 15. That's 8 equals the square root of 49 plus 15. That's 8 equals the square root of 64. 8 equals 8. That checks. That's a solution. We check negative 2. I have negative 2 plus 1 equals the square root of 7 times negative 2 plus 15. I get negative 1 equals the square root of negative 14 plus 15. Negative 1 equals the square root of 1. That means negative 1 equals 1. That is not true. This was not a solution for the equation. So our only solution here is x equals 7. We want to be careful there. X equals negative 2 is not one of our solutions. We checked it back in here. It did not work. Okay? We could have figured that out possibly early on here. Negative 1, we had a square root equaling a negative. We're never going to have a square root equaling a negative. We're not dealing with any imaginary units here. So that would never be equal to a negative 1. Negative 2 is not a solution. Not because negative 2, not because this number is negative. We could plug some negatives in and they could work. But this square root's never going to equal negative. And we can see that down here. So our only solution that worked was the x equals 7. Now we'll try another example here. Our first step on this is to square both sides. We're squaring the x plus 3 to FOIL it. So I'm going to have 10x plus 9 equals x squared plus 6x plus 9. Now to solve this, I want to get it set equal to 0, so I'm going to subtract 10x and subtract 9. I'm going to subtract 10x. I'm going to subtract 9. Let's cancel. I get 0 equals x squared minus 4x plus 0. We don't have to write that part of it. Now this factoring is a little different. We're not going to have two binomials. We can take out a common factor of x. So we factor an x out of both these terms, and we're left with the x minus 4. Now we can still set these each equal to 0. That's still why we do this. So we're going to have 0 equals x, and 0 equals x minus 4, which means x equals 4, x equals 0. We need to check these solutions. We need to plug them back into the original equation. So if we check x equals 0, we're going to have the square root of 10 times 0 plus 9 equals 0 plus 3. That's the square root of 9 equals 3. 3 equals 3. That checks. That was a solution. Now we'll plug a 4 in. We get the square root of 10 times 4 plus 9 equals 4 plus 3. It's the square root of 40 plus 9 equals 7. Square root of 49 equals 7. So we get 7 equals 7. Both answers work. You're not always going to get an extraneous solution. Extraneous means extra solution that doesn't work. Okay, in this case, both 0 and 4 are solutions to the original equation. They're both answers. That's fine. We're not always going to have one that cancels out, or that doesn't work, excuse me. All right, before we look at a couple other examples here, first I want to take a brief break for some alliteration. What is alliteration? Alliteration is what you see in brief break. It's two words that start with the same consonant sound. Brief break is an example of alliteration. There's many examples of alliteration out in the real world. If you email me before school starts next, you can get some extra credit by emailing me an example of alliteration in the real world. So just email me any example of alliteration and receive a couple extra credit points. All right. Now let's look at another example of a solution, or excuse me, a radical equation to solve and find solutions and check them. So in this case, we have a radical on both sides of the equal sign. That's okay. We can still square it to get rid of the radical on both sides. So we're going to square both sides of this. Move that down a little bit so we can get that writing in on the top. And we'll end up with 2x plus 5 equals x plus 7. Now we can solve this for x by subtracting x on both sides and getting it by itself. So I subtract x on both sides, gives me x plus 5 equals 7. I then subtract the 5 on both sides and get x equals 2. We're going to check that by plugging it back into the original equation. 2 times 2 plus 5 equals the square root of 2 plus 7. So the square root of 4 plus 5 equals the square root of 9. The square root of 13 equals the square root of 9. Now I'm not sure that that's accurate. The square root of 13 doesn't equal 9. Okay, so we squared both sides. 2x plus 5. We square this side, cancels out. We get x equals 2. If I plug it back in, I get 4 and 5. That's the square root of 9. Excuse me, I screwed that up over here on this side. Right? I was already getting ahead of myself for the answer, so it's good to go back. Right? We check that out. That should be 4 plus 5, which is the square root of 9. So the square root of 9 equals the square root of 9. That's accurate. Right? It's the same on both sides. So x equals 2 is a solution. Okay? So it's good to check the answer. If it doesn't work, right, we go back through, we check those steps, we made sure there was no mistakes. Hey, we had made a mistake. Okay. So we catch that mistake and see that x equals 2 did in fact work. If you ended up with square root of 13 equals square root of 9, if that was actually how it worked out, maybe there's no solution. Okay, if x equal 2 didn't work. In this case, it does. All right, one more example here. I'm going to square both sides of this equation. Don't forget, we're squaring the x minus 6 to FOIL it. So we get negative 25x plus 6 equals x squared minus 12x plus 36. You can write it all the way out and FOIL it. Make sure you know how to multiply x minus 6 times x minus 6. And now I'm going to get this set equal to 0. I'm going to add 25x and subtract 6. I'm going to add 25x and subtract 6. Those all cancel on this side to give me 0 equals x squared plus 13x plus 30. So I'm going to factor that. I need numbers that multiply to give me 30 and add up to 13. So 3 and 10 both work. Right? Again, I can check with swings, make sure you know how to factor, FOIL, these types of things that we're going to see here as we're using them to solve these radical equations. So I'm going to get x plus 3 equals 0, x plus 10 equals 0, means x equals negative 3, x equals negative 10. Now we got to check both of these in our original equation. So first we'll check x equals negative 3. So that's going to be the square root of negative 25 times negative 3 plus 6 equals negative 3 minus 6. So we have the square root of 75 plus 6 equals negative 9. 75 and 6 is 81, so the square root of 81 equals negative 9. We should be noticing a square root equaling negative. And this doesn't look very good, very promising. Negative 9 does not equal positive 9, so negative 3 is not a solution. Now we're going to check negative 10. X equals negative 10. I get the square root of negative 25 times negative 10 plus 6 equals negative 10 minus 6. We can see on this side we're going to get negative 16. It doesn't really matter to me what we have over here. Whatever this square root is, when we square root it, I'm never going to get a negative 16. I can tell you right now, you can keep going through and checking and figuring it out if you want. This is not going to be equal. Okay, this isn't a solution either. So there's no solution. And that's possible. If you get no answers at work, okay, there's no solution. There's no number for x you could plug into that original equation, ever have it work. Right? So we've seen solving quadratic equations, or excuse me, radical equations where we have quadratics that we have to work with, and we're foiling, factoring, okay? And now we got to make sure that we're checking those answers, because there are times where you're going to get answers you think might work that don't.